Welcome back to the session on Fourier integral representations. In this session, we shall discuss some example problems for Fourier integral representations. If f of t is an even function, then the corresponding Fourier integral representation is f of t equal to integral from 0 to infinity a omega cos omega t dt, cos omega t d omega, where a omega is given by 2 by pi into integral from 0 to infinity f of t into cos omega t dt, and f of t is odd. If f of t is an odd function, then the corresponding Fourier integral representation is integral from 0 to infinity b omega into sin omega t d omega, where b omega is given by b omega is equal to 2 by pi into integral from 0 to infinity f of t into sin omega t dt. Now consider one example. Find the Fourier integral representation of the function f of t given by f of t is equal to minus 1 for minus 1 less than or equal to t less than 0, f of t equal to 1 for 0 less than or equal to t less than 1, and 0 in other cases. Here we can verify that this function is an odd function or even function. Clearly, this function is an odd function because the graph of given function is like this, from minus 1 to 0, minus 1, 0, 1, minus 1 to 0, graph of function is minus 1 means like this. From 0 to 1 it is 1. Therefore, portion of graph is towards the left side here, and here 1 unit rightward direction. Therefore, and all the other cases function is defined as 0 means this function is an even function. The corresponding integral representation is in odd case function. If function is odd, this is the representation f of t equal to integral from 0 to infinity b omega into sin omega t d omega, where b omega is given by this expression, that is b omega is equal to 2 by pi into integral from 0 to infinity f of t into sin omega t dt. That is, we have to split this range 0 to infinity as integral from 0 to here 0 to 1 f of t into sin omega t dt plus integral from 1 to infinity f of t into sin omega t dt. That is equal to 2 by pi into, in this case the function is defined as 1, 2 by pi into integral from 0 to 1, 1 into sin omega t dt. Here t is varies from 1 to infinity means which will become this case function is 0. Therefore, value of this integral is 0. This is equal to 2 by pi into integral of sin omega t is minus cos omega t divided by integration is with respect to t, therefore divided by omega. Coefficient of t is omega between the limits 0 and 1. This is equal to 2 by omega into pi. When t equal to 1, this negative sign can be taken outside. Cos omega minus, when t equal to 0, cos 0 is 1, cos 0. That is minus 2 by omega pi cos omega minus 1. This is the value of b omega. This can be written as 2 by omega pi into 1 minus cos omega. And the corresponding function is f of t is equal to integral from 0 to infinity 2 by omega pi into 1 minus cos omega into sin omega t d omega. This is the required Fourier integral representation of this function. Here, by drawing a graph of this given function, we can identify that this function is an odd function. Therefore, we have to evaluate b omega only, and the corresponding representation is this. Now, consider another example. F of t is equal to e raised to minus mod t, e raised to negative of mod t for minus infinity less than t less than infinity. Here, the given function is even function, because for t here is a modulus. Mod t is always even, therefore, e raised to minus mod t is always even. There is no change. If we replace t by minus t, this will become e raised to minus of minus mod t, means e raised to minus modulus of minus t is minus t. Therefore, f of minus t equal to, this is our f of t. The given function is an even function. In this case, the corresponding Fourier integral representation is f of t equal to integral from 0 to infinity a omega into cos omega t d omega, where a omega is given by this expression, that is a omega equal to two by pi into integral from 0 to infinity f of t. In this case, here f of t is e raised to minus modulus of t into cos omega t dt. That is 2 by pi into integral from 0 to infinity. Here the range of t is from 0 to infinity. In this range, absolute value of t means t itself. Therefore, e raised to minus mod t can be written as e raised to minus t into cos omega t dt. This is equal to 2 by pi into value of this integral is, we can write this as e raised to minus t divided by 1 plus omega square into minus cos omega t plus omega sin omega t between the limits 0 and infinity. This is equal to 2 by pi into, when t tends to infinity, this will become 0 minus, when t equal to 0, here e raised to 0 is 1. This is minus cos 0. Minus cos 0 is minus 1. Sin 0 is 0. Therefore, minus of minus 1 divided by 1 plus omega square. That is 2 by pi into 1 by 1 plus omega square. This is the value of a omega, and the corresponding representation, Fourier integral representation, is f of t is equal to integral from 0 to infinity 2 by pi into 1 by 1 plus omega square cos omega t d omega. This is the required Fourier integral representation. Here the function is an even function. Therefore, in the corresponding Fourier integral representation, there is only cosine term. Now consider another example. Find an integral representation of f of t equal to, the given function is f of t equal to 1 minus t square for mod t less than or equal to 1 and 0 for mod t greater than 1, and hence evaluate integral from 0 to infinity. After finding the Fourier integral representation of this function using the representation, we have to evaluate integral from 0 to infinity sin x minus x into cos x divided by x cube into cos x by 2 dx. Here the given function is clearly, this function is an even function. Therefore, we have the Fourier integral representation as f of t is equal to integral from 0 to infinity a omega into cos omega t d omega, where a omega is given by a omega is equal to 1 by pi into integral from 0 to infinity f of t into cos omega t dt. Here the function is defined as 1 minus t square for mod t less than or equal to 1. Mod t less than or equal to 1 means t is in between minus 1 and 1, including minus 1 and 1. We can write mod t less than or equal to 1 as minus 1 less than or equal to t less than or equal to 1. Mod t greater than 1 means t is greater than 1 or t is less than minus 1. T is greater than 1 and t is less than minus 1. Therefore, this integral will become integral from 0 to 1. We have to split 0 to infinity as 0 to 1 and 1 to infinity. This 1 by pi is common into integral from 0 to 1 f of t into cos omega t dt plus integral from 1 to infinity f of t into cos omega t dt. That is equal to 1 by pi into, here the function is defined as 0 to 1 means 0 is in between minus 1 and 1. Therefore, In this case, function is defined as 1 minus t square. Integral from 0 to 1, 1 minus t square into cos omega t dt plus, here 1 by pi is common. In this case, 1 to infinity. 1 to infinity means t greater than 1. In this case, the function is defined as 0. Therefore, the second integral will become 0. This is equal to 1 by pi into, here we use the integration by parts, that is first function into integral of the second. Integral of cos omega t with respect to t is sin omega t divided by omega minus derivative of this function 1 minus t square. Derivative of 1 minus t square is minus 2t into integral of this. Integral of sin omega t is minus cos omega t divided by omega. 1 omega is already in the denominator. Therefore, omega into omega plus derivative of minus 2t, that is minus 2 into, once again integrate this function, that is integral of minus cos omega t is minus sin omega t divided by omega. Here omega into omega is in the denominator. Between the limits 0 and 1. This is equal to 1 by pi into 1 minus t square into sin omega t by omega. Here there are 3 negatives, therefore, in effect this will become negative 2t into cos omega t divided by omega into omega is omega square. Here there are 2 negatives, therefore, in effect it is plus 2 into sin omega t divided by omega into omega is omega cube between the limits 0 and 1. When t is equal to 1, this term will become 0. Therefore, this is equal to 1 by pi into, this is 0 minus, when t equal to 1, this is 2. 2 into 1 means 2 cos omega 1 divided by omega square plus 2 sin omega divided by omega cube. When we apply the lower limit 0, the first term will become sin 0, means 0. Therefore, this will become 0. Here, when t equal to 0, 0 into cos omega t by omega square is 0. This term also will become 0. Therefore, this is equal to, in this expression for omega, here is 2 by pi, not 1 by pi, it is 2 by pi. Therefore, this is equal to this 2 by omega square, omega cube can be taken outside. Therefore, this will become 4 by pi into omega cube. Here sin omega minus here omega cos omega. This is the value of a omega. And the corresponding representation is given by f of t is equal to integral from 0 to infinity a omega is 4 by pi omega cube into sin omega minus omega cos omega, omega into cos omega, this is a omega into cos omega t d omega. This is the corresponding Fourier integral representation of the given function. Now, we want to evaluate this integral. Comparing this integral with this expression, here instead of omega the variable is x. We can change omega by x because this is a definite integral. In the definite integral we can change the variable. This is equal to, we can write integral from 0 to infinity. This 4 by pi can be taken outside. Four by pi into integral from 0 to infinity sin x minus x into cos x divided by x cube into cos xt dx. Now, comparing with this once again, here cos xt, in this integral it is x by 2, that is for t equal to 1 by 2 we get cos x by 2 from here. Therefore, putting t equal to 1 by 2 we get, note that here t equal to 1 by 2 is not a point of discontinuity because 1 by 2 is lying between minus 1 and 1. Therefore, t equal to 1 by 2 is a point of continuity. We can evaluate at t equal to 1 by 2 as f of 1 by 2 is equal to 4 by pi into integral from 0 to infinity sin x minus x into cos x divided by x cube into cos x into 1 by 2, that means cos x by 2 dx. That is here f of 1 by 2 means 1 by 2 is in this interval. Therefore, function is 1 minus t square means 1 minus 1 by 2 the whole square. That is 1 minus 1 by 2 square is equal to 4 by pi into integral from 0 to infinity sin x minus x into cos x divided by x cube into cos x by 2 dx. That is here 1 minus 1 by 4. 1 minus 1 by 4 means 4 minus 1 divided by 4, that is 3 by 4 is equal to 4 by pi into integral from 0 to infinity sin x minus x into cos x divided by x cube into cos x by 2 dx. That is, this integral value of the integral is integral from 0 to infinity sin x minus x into cos x divided by x cube into cos x by 2 dx is 3 by 4 into pi by 4. 3 by 4 into pi by 4. That is 3 pi by 16. This is the value of this integral. Now, we have to consider another example, another type of example using the Fourier integral representations. The question is using Fourier integral representations, show that integral from 0 to infinity sin omega divided by omega into cos omega t d omega is equal to pi by 4. Value of this integral is pi by 4 for x equal to 1 and x equal to minus 1, and value of this integral is pi by 2 for x is in between minus 1 and 1 and is equal to 0 elsewhere. We have to show that value of this integral is like this using the Fourier integral. This integral is a Fourier integral representation of an even function, because this is of the form integral from 0 to infinity a function of omega into cos omega t d omega. Here sin omega t is absent. Therefore, this integral is a Fourier representation for an even function. Now, assume that f of t is equal to this pi by 4. Here we write pi by 2 for minus 1 less than x less than 1 and 0 otherwise or elsewhere. This function is clearly an even function because this is a constant function, it is even. Therefore, the corresponding Fourier representation, Fourier integral representation is f of t is equal to integral from 0 to infinity a omega into cos omega t d omega, where a omega is given by 2 by pi integral from 0 to infinity f of t into cos omega t dt. Here this is equal to 2 by pi into the function is defined as like this minus 1 to 1, it is pi by 2 and 0 otherwise. Therefore, we have to split this integral 2 by pi into integral from 0 to 1. In this case f of t is pi by 2 into cos omega t dt plus integral from 1 to infinity. In this case 1 to infinity means function is defined as 0. Therefore, value of this integral is 0. This is equal to 2 by pi into pi by 2 means 1, integral from 0 to 1 cos omega t dt. That is integral cos omega t dt is sin omega t divided by omega between the limits 0 and 1, that is sin omega into 1, that is sin omega divided by omega. When t equal to 0, this will become 0. That is therefore, we get a omega as sin omega divided by omega, and the corresponding representation is f of t is equal to integral from 0 to infinity a omega is sin omega divided by omega into cos omega t d omega. F of t is we have taken f of t as pi by 2 for minus 1 less than x less than 1 and 0 otherwise. Therefore, we have to substitute value of f of t as this. Then here note that x equal to 1 and x equal to minus 1 are 2 points of discontinuities, in which case the value of this right hand side integral is the left average of left hand limit and right hand limit of x equal to 1 and similarly for x equal to minus 1. At x equal to 1, the right hand limit f of 1 plus is equal to zero and f of 1 minus is equal to pi by 2. at x equal to minus 1, the right hand limit is pi by 2, and f of minus 1, that is the left hand limit at minus 1, is 0. Therefore, we have to write the value of this integral as, in this case, at x equal to 1, the value of this integral is 1 by 2 into 1 by 2 into 0 plus pi by 2, that is pi by 2, which is equal to pi by 4. Similarly, at x equal to minus 1, this is at x equal to 1. Similarly, for x equal to minus 1, value of this integral is 1 by 2 into pi by 2 plus 0 means pi by 2, that is pi by 4. Therefore, we can express f of t as, or the f of t is this integral. We can express this integral as by collecting all the values of f of t. We can express integral from 0 to infinity sin omega by omega into cos omega t d omega, which is equal to here pi by 2 for minus 1 less than x less than 1, and it is pi by 4 for x equal to 1 and minus 1, and 0 in all other cases. With this example, I would like to conclude this session. Thank you for listening the class. Have a nice day.